Hey Pre-Calc, let's take a look at synthetic division and PRZs. Okay, synthetic division is great when you want to divide polynomials when the divisor is linear. Okay, divisor is linear. That means that it's x to the first power. Okay, and the leading coefficient is 1. Okay, so it's like this. So for example, it has to be something like x plus 5. That's 1x to the first power, or maybe, for example, it's x minus 7. These are the only ways it can be. Okay, and so here's how you do it. You get a little box going here, okay, and you're going to put the 0. You're going to put the 0 from the factor. And then here you're going to put your polynomial with oxes. Oxes are 0 x's. Then you leave a little bit of space, and you're going to divide. Okay, let's go through a couple, just till you get the hang of it. So we're going to use synthetic division to divide this polynomial by this one. Can we do synthetic? Yes. Yes, because this is linear with a power of 1. Okay, so what we're going to do right here is in the little box, we're going to put the 0. The 0, or another word for that is the x-intercept. Okay, so we're going to put -2. All right, so right here, you have to change. You have to change what you see in parentheses. Okay, so that is another way of saying the x-intercept. Now the polynomial that I'm dividing, we're just going to put the coefficients. So that's the third power. The quadratic term is a 3. And then we have a 2. And then we have a 1. Okay, and then you leave a little bit of space. So to do synthetic, the first thing you do is you drop it down. Okay, so step 1, you always drop, and we have a 5. Now we're going to multiply. -2 times 5 is -10. Okay, so you're going to multiply, and then we're going to add these together to get -7. Now -2 gets multiplied by -7 to make 14. You add these together to get 16. -2 times 16 is -32, and we have -31. Okay? So right here, this last number I like to box off, this is the remainder. This is the remainder, okay? So did this divide in evenly? No, because there's a remainder, okay? If it was a factor, I'd have to write it in factored form, okay? But it is not a factor, so let's just say x plus 2 is not a factor. Okay? We don't really care about the ones that aren't factors. We have to keep going until we find something that does divide it. Okay? We want to factor these polynomials. Let's try again. Let's divide this polynomial by this one. Okay? Since this is a linear term, the x-intercept, or the 0, I'm testing is 1. Now the coefficients of this polynomial, okay, that's 1x to the 5th. But we're going to have to add some zeros. I don't see any x to the 4ths. There's 0x to the 4ths. There's 0x to the 3rds, x squared, x to the 1st, but the constant is -1. So you need to add all the terms in. You have to have a column for every power. To the 5, to the 4, to the 3, to the 2, to the 1, to the none. All right, now that we got it set up, let's go ahead and start our synthetic division. Step 1, you drop it like it's hot. 1 times 1 is 1. 0 plus 1 makes 1. 1 times 1 is 1. 0 plus 1 makes 1. 1 times 1 is 1. Adds to a 1. 1 times 1 is 1. 1 times 1 is 1. Oh, here we go. Finally something exciting. You add them together, and that, okay, box it off, get that out of the way, is the remainder. The remainder, okay? So this one actually did divide in evenly, okay? This is a factor, okay? It is a factor. Now, if it is a factor, we have to write this polynomial in factored form, okay? So f of x equals, the factor that I tested was x minus 1. Okay, so first you put the factor, okay, and then the second set of parentheses, you are going to put the quotient. The quotient is the answer to the division problem. So if this was x to the 5th power, the answer is always 1 power less. This is going to be x to the 4th power. So we have x to the 4th plus 1x cubed plus 1x squared plus an x plus a 1. Okay? That one doesn't count. That's the remainder. This last number right here is always going to be the constant. The constant gets no variable. And if I were to multiply x times x to the 4th, that would make x to the 5th. Okay, so this is exactly how we're going to write our answers. And this is exactly what we're going to be doing this chapter, trying to factor. All right, let's try again. There we go. Use synthetic division to see if x plus 4 is a factor. Okay, so I'm going to put in the box, in the little divide box here, a -4. And the coefficients for this problem, 1x to the 6th. Oh, time for an ox. 0x to the 5th. -16 for the power of 4, but there are 0x cubes. 1x squared, 0x, and then the constant down to the number. To the 6, to the 5, to the 4, to the 3, to the 2, to the 1, to the none. Okay, just checking that I had all the columns before I started. Okay, it won't come out right if you don't add in a column for every term. Step 1, drop it like it's hot. -4 times 1 is -4. Combine these, add these together, -4. Negative times negative makes positive. Add these together, 0. Something times 0 makes 0. Something times 0 makes 0. 1. -4 times 1 is -4. Add them together. Negative times negative makes positive. Okay, and box this off. Was this a factor? And yes, it is a factor. It is a factor. Yes. Okay, yay. As soon as you find something that is a factor, okay, you go ahead and you write f of x in factored form. All right, so I want you to notice here what's happening. F of x used to be a 6th degree polynomial. Okay, he's a 6th degree. He's got x to the 6th. He's still going to be x to the 6th down here. He's just going to be in factored form. Okay, so the factor that we found was x plus 4. Okay, there's the factor. Here's the factor. And then the answer that we got, okay, the quotient is right here. So this used to be a 6th degree, a 6th power, but I took 1x out. So now this is always 1 less. So we have x to the 5th minus 4x to the power of 4. There's no x cubes. The power of 3, the power of 2. I'm going to skip to here. Okay, this is the power of 1x, the linear term, minus 4. Okay, if I were to multiply x times x to the 5th, f of x is still a 6th degree polynomial. He still has 6 x's. He's never going to get smaller. We're just factoring him. Now let's go over a couple things here. Can you divide with a fraction? And the answer is yes, of course you can. Okay. Is 1/2 a 0? Is this a 0? All right, let's go see. We're going to put 1/2 in the divide box. Do we need any oxes? X to the 3rd, x to the 2nd, x to the 1st, and then my constant. Okay, I didn't need any oxes, so we're just going to use these 4 numbers, and let's begin. Step 1, drop it down. Half of 2. Half of 2 is 1. Add them together. What's half of -8? Or you could say -8 divided by 2 makes -4. What's 6 divided by 2? 3. Ah, look at that. Look at that. The remainder is 0. Okay, and so yes, it is a factor. It is a factor. Okay, so we're going to write it in factored form. f of x equals, okay? Do you remember what we have to do here? You have to change the sign. So if this is a positive, we're going to say x minus 1/2. All right, this problem started off as x to the third power, so this is going to be x to the second. 2x squared minus 8x plus 6. Okay? So yes, it is possible to do fractions. Now let me tell you something else that has to happen when a fraction works. Maybe we'll write a note down here. Okay? When a fraction works, we must clean it up. Oh, how do we clean it up? Okay, so I know that this factor right here, I want to get rid of the fraction, would really love to get multiplied by 2. Okay, and where do we get a 2 from? From the quotient. Okay, so he wants a 2, wants to be multiplied by 2. Wants to be multiplied by 2. Okay, so what we're going to do here, let's just write down f of x, of course, x minus 1/2. I'm going to look at this polynomial over here, okay, and I'm going to factor out a 2. Factor out a 2. So now he is x squared minus 4x plus 3. Okay. Now what are we going to do with that 2? We're going to use it to distribute it into here, okay? So we're going to distribute into the factor. Distribute it in, okay? So that's going to give us f of x equals 2x minus 1. And then we have this other quadratic right here, okay? So whenever you have a fraction that works, we have to clean it up. Let's take a look at how this would multiply out. What's 2x times x squared? That would make 2x cubed. And my problem had a 2x cubed. Okay? So that's a little trick with fractions and what you have to do when you get a fraction as your factor. All right, let's keep going. Okay. How do you know which factors to try? Okay, how do you know what factors to try? There are an infinite number of numbers that you could possibly try. Okay, but what we're going to do here is use this test. Okay, P stands for possible, or sometimes people say potential. Okay, potential rational zeros. The possible rational zeros. Okay. And here's how you make that. Okay, so PRZs are as follows. You get a nice big fraction bar going. Okay. In the numerator of the fraction, we're going to put plus and minus all the factors of the constant. All the factors of the constant. Okay, if your constant is that number at the end with no variable. And then in the denominator of this huge fraction, plus and minus all the factors, okay, of the leading coefficient. The leading coefficient, I-E-N-T. The leading coefficient is the coefficient from that first term. Okay. And then I do have to make a little note here. Okay, we must make all possible combinations. What? All possible combinations of those numerators and denominators. Okay, so let me walk you through a couple of them. List the PRZs, okay, for this polynomial. So the PRZs are as follows. PRZs, okay, I'm going to take 10. Let's use blue just to color code like we did our notes here. All the factors that go into 10. Okay, so let's see. Plus minus 1 goes into 10. Plus minus 2 goes into 10. 3 does not divide in, nor does 4, but 5 does. Okay, now I know that 5 times 2 is 10. So you don't really have to think about all the other numbers. 5 times 2, and then what number goes with 1? 10. Okay. Once you find the two numbers that match, you just have to work your way back out. All right, now in the denominator, we have to look at, this is the numerator, the factors of the leading coefficient. So what number can go into a 5? Well, plus and minus 1 and plus and minus 5. Okay? But now comes the fun part. You have to make all possible combinations. Okay, so let's start with the numerator 1. 1 has to get divided by 1, which is going to make a 1. Okay? Let's take 2 and divide him by a 1. And that's going to make plus minus 2. 5, you get divided by 1, plus minus 5, and plus minus 10. Okay, so I divided all of these numerators by 1. Now I have to divide them all by 5. 1 divided by 5 makes 1/5. 2 divided by 5 makes plus and minus 2/5. You must write plus and minus on all these terms. There's actually double the amount of numbers here. What's 5 divided by 5? Well, since that's a 1, I already have it. I'm not going to write it again. 10 divided by 5 is 2. I already have it. I've made every possible combination. Okay? So if I were to take this polynomial and start trying PRZs, should I try 3? No, 3 is not even in this list. 1 might work, 2 might work, or they might not work. Okay? But at least I have a smaller list of numbers to try. Okay? So try these numbers. Okay? Try these numbers to see which ones work. To see which ones work. Okay? But let's just make a note here. Okay? They all don't work. They all don't work. In fact, sometimes hardly any of them work. Okay? But if a number is going to work as the factor, it's got to be from this list. Okay, let's practice again. Let's make a list of PRZs for this polynomial. Okay, so PRZs. In the numerator, we're going to write all the factors of our constant, which is 6. So we're going to start with plus minus 1, plus minus 2, plus minus 3. 3 goes with the 2, so then the 6 must go with the 1. Okay, and then in the denominator, all your factors of 2. Plus minus 1, plus minus 2. All right, now it's time to make every single possible combination. So the PRZs are, let's divide them all by 1. 1 divided by 1, 2 divided by 1, 3 divides by 1, and 6 divides by 1. Okay, 1, you're done. Now they have to get divided by 2. Plus minus 1/2. 2 divided by 2 is 1. I already have that one. Oh, I don't have 3 halves yet. 3 halves. 6 divided by 2, I already have. These are the list of possible rational zeros. These numbers might work. If I were to say start factoring this, start trying some factors, should I try the number 7? No, 7 is definitely not going to work. Okay, you only want to try numbers from this list. Okay, it's time for you to try a little bit now. Okay, I want you to see if this is a factor. The way that you see if something's a factor is with synthetic division, and if it is, then you write it in factored form. Okay, so that's kind of what we did on the first couple pages. You test, and then you write it in factored form. Okay, so I want you to try 1, 2, 3. And then for number 4, these directions, I just want you to list the PRZs like we did on that last page, okay? We're not actually testing anything. You're just making a list of PRZs. Thanks, Pre-Calc.